Hello everyone, I am Jagdish Patel, Assistant Professor, Sandeep Foundation, Nasik. The name of subject is Broadband Communication System. This one is Unit 2, Light Wave Systems. Lecture number 3, in which we are going to see Design Guidelines in Fiber. I am having 12 years of teaching experience, specialization in digital communication. What is optical fiber? A thin strands of pure glass carry data over long distance at very high speed. Fiber can be bent or twisted. Fiber optic technologies. It consists of source, transmission media, and detector. Here we are applying the signals, input signals from various sources to an optical transmitter. Optical transmitter is a device which is used to transmit the signal over a transmission medium. Medium consists of optical fiber cable. This signal is given or detected by optical detector which is present in optical receiver side, and after that the signal is given to the end user as signal output. Two-way optical transmission. Transmission 1 and transmission 2. Given to the optical multiplexer. Optical multiplexer merge the signal and give it to the optical glass fiber link. After that, on the receiver side, optical multiplexer used to collect the signal and it is given to the receiver 1 and receiver 2. So in this way, the two-way communication takes place. Optical communication. The information is receiving or coming from the source end will be given to the light sources. After that, this signal is given or transmitted on a glass fiber. After that, the thickness of the fiber is 125 to 50 micrometer, and then photodetector used to detect the signal and transmit that signal over the information channel. And in this way, the optical communication takes place. Elements of optical fiber transmission system. It consists of the main elements is transmitter, which consists of light source, which is present in the input side. After that, the signal is given to the repeater, which consists of photodetector and again light source. The signal of the repeaters are given or transmitted over fiber cable. And on the receiver side, there is a photodetector, which is used to detect the photo signal coming from the fiber and transmit the signal to the original information to the end user. Fiber optics. Optical glass fiber. Propagation, technologies and application. Attenuation, dispersion, chromatic, there are two types, material and waveguide. Multi-mode fiber and single mode fiber. In multi-mode there is a step index and gradient index. Zero dissipation shifted and flatter fiber. So these are nothing but the fiber optics. There are different types of ways or fibers. Zero dissipation shifted fiber. Advantages. Smaller size, lightweight, non-reactive, larger bandwidth, high data rate, low loss, long repeaterless span, no EMI, RFI, crosstalk, non-inductivity. Source of light. Light emitting diode, that is LED, and laser. These are the sources of light through which the signal is transmitted over the optical fiber cable. Modulate electric signal into optical signal. What does this devices does? It modulates the electric signal into the optical signal. Mostly modulated at 850 nanometer, 1300 nanometer and 1550 nanometer. Laser gives high intensity, high frequency light. LED are economicals which are easily available all over. Transmission media. Optical fiber is replacing copper. Light is used as a carrier of information, and the most important is much higher data rates. It consists of core, it consists of cladding, and there is a coating over it. Combinedly gives the optical fiber. Physics of optical fibers. Index of refraction of material, ratio of speed of light in vacuum to the speed of light in medium. Refraction of light. bending of light as it travels from one media to another. Refraction of light. Speed of light changes as it across the boundary of two media. If you observe here, the light rays are incidented on the surface. After that, they are transmitted into or refracted into the another media, right? Angles with respect to the normal. Here there are two angles it forms, incident angle and a refractive angle. Refraction indices, vacuum 1 exactly, air 1, alcohol 1.3, diamond 2.4, glass 1.5, ice 1.309, sodium chloride that is salt 1.544, sugar solution that is 80% 1.49, water 20 degrees Celsius that is 1.333. So these are the refractive indexes of fibers. Snell's law. Snell's law is nothing but n1 upon n2 is equal to sine theta 2 upon sine theta 1. Where theta 1 and theta 2 are nothing but it is called as critical angles. n1 and n2 are the refractive indices. If you observe in the diagram, there is a fast medium and there is a slow medium. In fast medium, smaller index of refraction that is theta 1 and n1, and in slow medium, greater refractive index that is theta 2 and n2. Critical angle that is angle of incident at which the angle of reflection is equal to 90 degree is called as critical angle. And due to which above this critical angle the internal reflection, total internal reflection takes place. If you observe here, total internal reflection, trapping light in the fiber. Here there is a core, there is a cladding and critical angle. If you observe here, there is a critical angle, right? And above this angle, there is the internal reflection take place. So to observe the internal reflection, the angle should be greater than critical angle. Fiber can be bent. If you observe here, the fiber can be bent. It is flexible. So here there are two lights of signals. That is, one is blue and another is red. So internally they can travel in this fashion through the fiber. Types of optical fibers: single mode and multi mode. Only one in single mode, only one single signal can be transmitted. Uses of single frequency. In multi mode, several signals can be transmitted. Several frequency used to modulate the signal. Losses in optical fibers. There are three different types of losses: attenuation loss, dispersion loss, and waveguide loss. Splices and connectors. To connect the fiber mechanically or by fusion, lot of signals lost possibly, very accurate alignment necessary, most important cost factor, now being replaced by optical amplifier. Optical receiver must be very sensitive, capable of picking up and amplify signals of nanowatts, photodiodes and phototransistors. This device gets turned on by light, produce photocurrent. Advantages of optical fiber: can carry much more information, much higher data rates, much longer distance than coaxial cable, immune to electromagnetic noise, light in weight, unaffected by atmospheric agents. And this one is the applications. We have seen this before also. Optical fiber can be used in wide range of applications. It can be used in railway, transmission, computers, internet, ethernet, biomedical, antenna propagation, submarines, ISDN, video gaming, international communication, and so on. So these are the wide range of applications where optical fiber can be used. Conceptual development of optical fiber: point to point, multi-wavelength transmission improved further with EDFA coming, capacity increases on existing system, broadcast and select network, concurrency, star network, simple, broadcast star switching fibers, switching in wavelength, domain-aware complexity, off-time and space switching, wavelength routing, selective routing of optical signal according to their wavelength as they travel through the network, wavelength reuse, WDM cross connect, rearrangeability through space switches, wavelength selective elements, add drop capability. Scalability, add more nodes. Wavelength reuse in multi-hop network, wavelength conversion. Wavelength translation, change wavelength beyond boundary of administrative domain, large scale network. Transparency, that is data format, network layering, optical connectivity layers, fiber SONET ATM, now fiber optics connection transport switching, network management, control and operation in transparent system, monitoring and control. So these were the modes of operation of the fiber, advantages of the fiber and applications of the fiber. Thank you.